Collinearity. Given the points P, -6, -3, Q, -2, -1, and R, 6, -3, express PQ and QR as column vectors, hence show that the points PQ and R are collinear. So collinearity means showing that these 3 points lie on the same straight line. So let's say if that is point P, point Q should be there and R should be there. So when you're showing that these points are collinear, we simply want to show that the points lie on the same straight line. So that is the meaning of collinearity. Now, in showing that these points are collinear, we need to show 2 things. One, that the two vectors are parallel, and in this case is vector PQ and QR. Then number 2, we need to show that there is a common point between the vectors. So when we show these 2 things, we have shown that these 2 vectors are collinear, or these points are collinear. These 3 points are collinear. Now let's begin with showing that the 2 vectors are parallel. So we start by expressing PQ and QR as column vectors. So we express them as column vectors. So PQ as column vectors. But first let's express PQ. This will be given by, so it will be necessary for us first to write these vectors as column vectors. So we can begin by giving, this is vector P, which will be given by -6, -3, then Q, -2, -1, R, 6, 3. So we have expressed them as column vectors first. Then now let's get PQ. So vector PQ is obtained by getting Q minus P. So Q is -2, -1, minus P, which is -6, -3. This gives -2. Subtract -6 will be -2 plus 6. -1 subtract -3 will be -1 plus 3. So this gives -2 plus 6 gives 4. -1 plus 3 gives 2. So that is PQ as column vector. Let's go to QR. Get vector R, which is 6, 3. Subtract Q, which is -2, -1. So this one gives 6 subtract -2 will be 6 plus 2. 3 subtract -1, 3 plus 1. This gives 8, 4. So we have expressed the 2 as a column vector. So observe these 2, vector PQ. So vector PQ therefore is given by 4, 2, and QR is given by 8, 4. Now I want to show that these 2 vectors are parallel, and when you observe the 2, you note that vector PQ PQ is a half of vector QR, or you can also write this one as QR can also be obtained by getting 2 PQ. So by showing this is a scalar that exists between the two vectors. We have already shown that the two vectors are parallel to one another. That is one condition. Condition number 2, so condition number 1, so you can write this one somewhere here. So condition number 1, we have shown that PQ is parallel to QR by showing that there is a scalar that exists between the two. And then you can see between PQ and QR that Q is common. That is condition number 2. There is a common point. PQ, QR, Q is common, and you have already shown, by showing these two, you have shown that these vectors are parallel to one another. So that is how you're supposed to show collinearity.